First, open ArcGIS, ArcMap, and we want to create a new map, a blank map, and click OK. To import data into ArcGIS, we go to our catalog, and first we want to create a folder to tell ArcGIS where our data is located. I've done that already, and my data is down here in my Dropbox. So you want to put your data either on your C drive or in Dropbox and not on some network drive, which will make ArcGIS load much slower. Use the data. First, let's load in countries. We simply just drag the data here, and we see the countries here. This is a shapefile with the extension SHP, and it consists of polygons, which are the countries here. We can right-click on the layer, open Attribute Table, and see the different types of information that's in our data. We will end up using the three-digit, three-letter code for country abbreviations here. Let's also load in the lights data, because the first thing that we will do today is to calculate light density per country. These are lights visible from space. And this is a raster file, which we see with the, since it has the extension TIF here. We load it in. And to see through the layers, we can click on the color of the countries, put no color here, put some borders that we can see more clearly, and then we can see our lights data through the country borders. We can zoom in, and it's see Europe is much more lit than the deserts in Africa. To calculate average lights per country, we want to go into our toolbox here. That's all the tools that are in ArcGIS. We find the spatial analyst tools. But before using this tool the first time, you want to go up into Customize, Extensions, and click Spatial Analyst. That's just the first time you use ArcGIS. You go into the Spatial Analyst tools, click on Zonal, and you want to do Zonal Statistics as Table. Here it asks for the zones data, that's the countries. Then you define the field that you want to calculate average lights within. That's our three-letter country abbreviations. The raster data that you want to load, that's the line. Then define where you want GIS to put it in an output folder that I've created. So we call this lights per country. We save, and we want GIS to calculate all types of statistics here. And let's zoom in to see what ArcGIS is now doing. So we see our pixels here in the raster file, and for each for each country, ArcGIS it calculates the average of the centroid of each pixel. So pixels where the centroid is located outside our countries will fall out. That will be a problem if we do a more disaggregated analysis across subnational districts in a country. Then you want to use the resample tool in your toolbox to make the pixels smaller. We can see the results in here. In the current session, Zonal Statistics is now done calculating. This is the output. We right click, open, and we see all the statistics that it's calculated on our data. The mean value for each country out here. So we can check if this makes sense here. In the top here, with the most lit country on average, that's Singapore. That makes sense. Now we want all our data to go into Excel. And first we will clear this, otherwise it'll just put into Excel what I've marked here. So we clear it. To put it into Excel, we go into our toolbox, choose Conversion Tools, Excel, Table to Excel. We put in the data that we just calculated and tell GIS where to put it. Save it, and it's done. We can open this file in Excel, and here we have all our data. Let's just throw that into this data. We copy it, open the data editor, paste the data. The first row is variable names, and we have our data here that we can merge with other data and do regression analysis across countries. Now, so the mean values here, that's lights per pixel per country. But what if we wanted lights per capita per country? Then we would use this sum of lights and merge our data with a country set of country population and get lights per capita. But what if we wanted to do this analysis across subnational districts? Then we want to go back into ArcGIS and get within each pixel, we want lights per capita. Then we need to load in per capita data or population data at the grid cell level. We have that here. Let's zoom it out. So I right click and click zoom to layer. Let's unclick the lights, and this is our population data. To divide the two layers by each other, we go again into Spatial Analyst tool. Now we want the map algebra and the raster calculator. We simply divide the two data sets. Lights divided by population. And this takes a couple of minutes to calculate, but I've cut out the waiting time, and here's the finished data. Let's close all these layers here. Otherwise, ArcGIS can run a little bit slow if we have all these data sets open. Remove them. Now we want to calculate average kilometer roads per country. We load in our roads data. We have all these roads. We can zoom in and look at all those roads. Let's say we wanted to calculate kilometer big roads and not all of these roads here. By selecting based on the scale rank variable in our data set, let's say this has to be smaller than 4. That means the big roads here. We want to create a data set just with these big roads. We go to selection and create layer from selected features. let's unclick the selection and change the color here so that we can more clearly see them. Now we want to have a data set which tells us which road goes through which country. That means that we want to intersect the two. So we go into Analysis Tools, Overlay, and Intersect. We choose first the country data, then the roads selection data. We define where to put it. Click OK, and it calculates. Here's the data. We right-click on it, open the attribute table, and we can see that we have our country abbreviation code here, and the length of the roads here, which was in the original data. Let's just put that into Excel. We open that. We mark it, copy it into data. And we want to calculate the total number of roads per country. To do that, we collapse the data. We want the sum of this variable here by our administrative units. There we go, and we see then the total length of roads for each country. But we want to scale this. We want to divide this by the area of each country. So we go back into ArcGIS. Now, until now, all the data sets are in a geographic coordinate system, which means a round world. We want to make that flat to be able to calculate areas. That means we want to project our country data. We do that in Data Management, Projections and Transformations, and Project. We put in here our country data. We tell GIS where to put it. We tell GIS which coordinate system to use. We choose the projected coordinate systems of the world. And we choose the sinusoidal, which preserves areas and which is the projected coordinate system that I usually use. Click OK. It's done projecting. We want to load in the data. These are the projected countries. We right-click to calculate the area, open attribute table. We add a field. Right-click on this new field here. Calculate the area, and we want this in square kilometers. This data set here again, we can just export to Excel and merge it with our roads data. There's just one thing to note, that our total roads here is only calculated for those countries that do have a road. All those countries without big roads, they do not enter in these data. So we want, when we merge with the areas, we put all the countries that have missing roads information, we give them a 0 road length, and they can then divide this by the area. The last thing that we want to do is to load in some data which we have latitude, longitude points on. Let me just show you the data. So in an Excel file, I have just some ethnographic societies in the ethnographic atlas, their name and their latitude and longitude of their location. To load this into ArcGIS, we go into our catalog, right-click on this Excel file, create feature class from XY table, and define which the X field at the X-axis in a coordinate system and the Y field, Y-axis, which is longitude and latitude. ArcGIS guessed correct. So we'll just leave that. And then we'll then choose the geographic coordinate system that latitude and longitude are based on. That's the WGS 1984 coordinate system, which I always use for world data. And we want to load in these points that it just created into ArcGIS. Here's the points. Let's zoom to the layer. And here we have it. Now let's get rid of these roads here, which makes it all a little bit slower. And all these other data here. They're projected as well. We want to calculate the distance to the ocean from these points here. Therefore, we'll load in data on where the ocean is located. There we go. And the tool that we want to use is in Analysis Tools, Proximity, and Near. We put in our points, we put in the ocean. And very importantly, now we want to tell GIS that we are still in a geographic coordinate system. This tool, this particular tool here, can actually calculate distances even though we did not project our coordinate system. As long as we choose geodesic. We click OK. These procedures here take a couple of minutes, but I've just cut them out from the video here. Let me just show you where these distances, this near tool has put these distances here. These distances measure the distance in meters to the ocean from each of these societies. And we can again export this to Excel and merge it with the rest of the data from the ethnographic atlas. Last, if you want to save all this work, you simply push the save button, which I've already done, but let me show you what it does. It's just like any other folder here that you save, and you can then open that another time. Another thing, if you've done some pretty complicated things and you want to save all the steps here, you want to do Model Builder. Let me show you how to do the distances in Model Builder instead. This search tool here you can use to search for tools. It's the near tool in the analysis toolbox. We drag this into our Model Builder, and what we then want to do, and then we can double click it and inform GIS again that we want to calculate the distance, the geodesic distance to the ocean from each of these societies. What we then want to do, we want to export this to Excel, table to Excel. We drag this in there as well. And then we choose the output. See, it names this number 2. We choose that output. And we want to put this into the output folder, press OK. So now if we run this entire tool here, it will create an Excel file with a close to the ocean dataset. We push this button to run it. Let's say we want to save this and work on it tomorrow. We save it. You just have to define the toolbox first. Let's call that toolbox. And ArcGIS can only save these model builders inside a toolbox. So we click that and save it as model. Then let's say that this is tomorrow and we want to edit our toolbox here. And find our toolbox in the output folder. This is our model. We right click and press edit. There we have our model. Last thing, if we want our map to go into a PDF file, we need to go into layout view instead. Click that. We can put in a legend, north arrow, and so on. We can then export our map into a JPEG file and save it. That's that.